This program meant for students of media studies and communication programs. In the communication background, since you are familiar with the newsroom operations, I'm giving one basic information about two statements. One says find the difference between 3.7 versus 7.3. Another statement says find the differences between 40 and 04. The statement I gave gives only numbers, doesn't say anything about the background, doesn't give any information about the context. So if you ask you to find the difference between 3.7 and 7.3 without context, at the most you will say this is the lowest number, this is the highest number, 40 and 04. Here also there is no context. So at the most we can say this is a reversal of numbers. It's a 10 times of 04, become a 40. Like that you can give a very generic information about these numbers. But when I give some brief context about these numbers, it's a 3.7 Richter scale, 7.3 Richter scale, earthquake measurement point. When you are in the newsroom, when you are getting a stories from the wire surveys, 3.7, it's a kind of mild earthquake. Think about the scenario of 7.3. It's a massive. So when the newsroom handled these two set of news item, think about the next day morning, what kind of stories will be published that. If it is 3.7, it's a mild earthquake, goes in the city news in a single column. If it is 7.3, it will be a talking point. It will be the main important story in the national media as well as in international media. 7.3 is a massive. Mild 3.7, massive 7.3. The difference is just a 4. But as a being in the newsroom operation, the person associated with the newsroom, you can find the difference and the word you are using, mild and massive. And similarly, if you are in North India, particularly in Indian context, if you are in North India, you can easily find the difference in terms of centigrade, Celsius. 40 is summer, very hot, and heat wave, climate crisis. We'll talk a lot about that scarcity of water and all this heat wave and everything. It's a May-June time. If it is a 04, it will be around December, January, and winter. We talk about more about air pollution and everything on that. So when we give the number without context, it doesn't make much sense of that numbers. When we give the number with the context, it makes a lot of difference. So that's the importance of numbers in the research. And in your routine life, we deal with a lot of numbers. Numbers are part and parcel of our routine life. We make a lot of meaning, a lot of information, a lot of understanding. Our understandings become more clearer if we deal with the numbers. Some of the example you can see that 85% of the lung cancers in men and 45% in women are tobacco related. Easily can relate with that. And you can relate in every situation in your life, personal life, professional life, very much part of research. We usually divide the research in two segments. One is a qualitative study, one is a quantitative. The qualitative study is a one confined to small area, go deeper into that context, and we are trying to interpret the scenario, and we are understanding the particular phenomena in a much more detail. It has a merits and demerits, and you can't generalize the findings coming out from qualitative study. The qualitative study is specifically for one community, one group, or a few individuals. We are trying to understand certain contexts and scenario with relation to communication media usage. So that is a qualitative, where we never use numbers. We rely heavily on text and our own understanding, interpretation, everything on that. On the other hand, we have quantitative studies. Here everything we are measuring. We measure everything in numbers. We'll quantify the behavior. We'll quantify the effects. We'll quantify the impact. We'll quantify everything here. Quantification is based on the percentages, based on the frequencies, averages, standard deviation, you'll find many terms associated with the quantitative studies. And in a quantitative study, we usually test the existing knowledge, either through the concept, constructs, theories, models, and either we will adopt the theory, we will develop a scale or adopt the scale and go to the new settings. We will collect the data, we analyze the data, and the data might either add new information to the existing knowledge or it refines the existing knowledge. When you are dealing with the numbers, we end up with sometimes if you are doing a survey, if you are dealing with 200, 300 people, and end of the survey, you will have massive data. It may not be big data, but it's a good number of data, because every questionnaire, you have multiple options. Each options are decoded with some numbers. Multiply that, you will end up with a big number of data. And then how do we take a meaning out of that numbers? We need a tool that gives a new understanding based on the numbers. That is called statistics. So if you look at the statistics role in any research settings, basically statistics is a way of getting information from data. We are deriving information from the data. And for that purpose, we are using the statistical as a tool. So this is the simplest definition of statistics. And without statistical understanding, and one can't undertake quantitative studies in a very meaningful manner. Basic understanding is required in order to start the quantitative studies. And over the period, with much more reading and experiences and understanding with numbers and statistics, you may go to the very sophisticated level, I think. So we have collecting the data through multiple methods. Through statistics, we are trying to interpret the data, we are getting information. So quantitative studies deals with the numbers. Through numbers, we can make out certain information or understanding only through statistical applications. So you can see the relationship between these three components: quantitative studies, numbers, and statistics. So statistics is a part and parcel of quantitative studies. Without having knowledge about statistics, undertaking a quantitative studies is a meaningless exercise. The basic understanding is required. At least you should have knowledge about what is the data and how data can be classified and how the data can be handled in a much better way. So the basic fundamental component of statistics is understanding data. So that's what we are going to discuss about in this program. The longer, lengthier definition of statistics deals with a couple of key terms. Basically, the statistics is a science of collecting, presenting, analyzing, and interpreting the data. And for all these purposes, statistics used heavily on that. How we can collect the data, sampling, scientifically we have to do the sampling, and once the data has come, then you have to make a proper presentation and do the proper analysis and do interpretations. For all these purposes, statistics is a very crucial part. I use the word sampling. This is very crucial in a quantitative studies. The qualitative study is confined to small setting that can't be generalized. Whereas in the quantitative studies, we are intended to study the whole population. Population means the whole area, in the whichever population you are taking might be in some thousands, millions, and billions. If we are taking a public opinion survey, exit survey immediately after the voting, for example, if Lok Sabha seat and it represents the entire country, and we have done a study within the 20,000 or 30,000 people. So based on the results from 30,000 people, we are projecting the projection for entire country. Whatever the percentage of people who voted for that particular election, 60%, 70 or 65% on that. So this is the population and this is a sample. So sample should represent the population. And in the quantitative study, whatever we are doing needs to be generalized to the population. So that's through sampling, we are reducing our time, we are reducing our efforts, needs lesser infrastructure, and do a simple study and with that data that can be projected for the entire population. This is a very simple procedure used in a quantitative study, but we have to do it in a very careful manner, and all the characteristics of population needs to be intact, needs to be maintained within the sample, then only it can be projected. So this is a scientific way of doing. Once you collect the data, and with the statistical application we can project the data for the entire population. We are saying quantitative studies or deals with the numbers. When you end up with a study, you will have massive data. Or if you are going on online mode, for example, if you are doing data mining or text mining of social media postings, in a day, in a month, on a year, if you are planning to study the campaign undertaken by the individuals towards a public cause from Indian Twitter accounts, you'll end up with lakhs and lakhs, millions of postings. Manually, we can't handle that. So that can be done through text mining. But once text mining, you got the data, and with a statistical application, you can understand the meaning of the campaign undertaken by various people for a particular public cause. So that is a relationship here. And in order to make this interpretation, and the statistics, we are saying with the data, you can make a information, you can derive new information, you can derive new understanding. But before that, you need to understand the data. Data, it looks like a very simple term, but that can be classified from the statistical point of view. And once you are clear with the understanding about the data, then you can handle your study in a much meaningful manner. So the data can be classified in basically 4 divisions. This we can call it as a levels of measurement. Levels of measurement refers to the precision of data collected for a research study, and what kind of data required, and that particular data can be handled by a particular set of statistical tools. You will understand the different types, and accordingly, once you know the types, then you can use the particular statistical tools. And it has implications for the statistical procedure that can be done. What kind of nature of data? Then we need that appropriate statistical tool. In a simple term, if you take a car and boat as a 2 set of data, it needs its unique infrastructure. The car we are using to drive or to move from one city to another city, we can use only the road facilities. Similarly, the boat is another set of data. It requires only the water facilities to migrate from one place to another place. You can't use it on the road. Similarly, if you have data A and it needs particular statistical tools, and you have data B, then that needs the particular statistical tools. Primarily, data can be classified into 4 types. We can call it 4 levels of measurement. One is a nominal, one is ordinal, one is interval, one is ratio. Nominal is a basic data type, and the next is ordinal, and the third is interval, highest is ratio. And this is the 4 levels of measurement, and we will come back to the 4 levels of measurement. In between, you understand the different types of data. Once you understand the different types of data, you can relate with these 4 levels of measurement: nominal, ordinal, interval, ratio. Data primarily can be classified into 2 types. One is a quantitative data, another one is qualitative data. This is nothing to do with the research methodology of qualitative and quantitative. Remember that's the methodology is different. Quantitative deals with the numbers and qualitative deals with the interpretation. And here we are talking about data types. Fundamentally can be classified into 2 data types: qualitative data, quantitative data. Qualitative data comes from that any area which is non-numerical categories. The categories are defined in terms of characteristics. You can define certain characteristics based on which data can be divided. Well, the simplest example is the gender, eye color, and car models, ratings, movie ratings, letter grades given for the exams. These are the classification of data based on the characteristics. Characteristics means the biological difference between male and female, other gender, we can classify them. So male, female, other gender. So these three transgender, like that you can classify the categories. These are group of people. And when you collect the survey, you will ask your gender, you'll ask them to identify the gender and decode the categories. Male means 2, female means 1, and transgender means 3, and LGBT means 4. Like that we can give one number for all the categories. We got the categories are decoded, and we got the numbers. Look at the qualitative data, characteristics based data, they are equal. Male, female, the difference is a biological difference, and or eye color or car models, there is a difference, but we can't measure the difference. Characteristics are different, but all are equal. When you come to the letter grading for exam and movie ratings, we are giving some grading: excellent, very good, good, poor, average, poor, something like that. These are representative based on the performance. Here you can find the difference between gender and movie rating. Gender, male, female, in a movie rating you can say excellent, very good, and poor. You can see some order. And here everything is equal, male and female and others are equal, and here the data is not equal, there is a hierarchy. Here we can place it in order: excellent, very good, and poor. But we don't know the difference between excellent and very good. We know the difference. We know excellent is better than very good is better than poor. But here male and female, we can't say better than a male, female is better, transgender is better. All the data are equal. The qualitative study also, we can have two set of data. We will come to that point later. But understand basically the qualitative data are generated based on the characteristics. And here whatever data is being generated, what the most we can do the counting only. We can't do the subtraction, we can't do the multiplication, we can't do the addition, everything. It's only counting and frequency we can measure that. So another set of data is quantitative data. Quantitative data consists of values representing the counts and measurements. Example of quantitative data is time taken by an athlete to complete 100 meters or 400 meters, or number of hours an individual spending with the mobile, with the social media, number of hours spending with the television prime time news. So here we are measuring the behavior in terms of numbers. 9 hours or 6 hours we are spending with a particular activity. Here everything is coming from some activity. The numbers are generated, has some meaning. These are actual numbers. Where in the qualitative data, we generated the data, we decoded with some numbers. The numbers are doesn't make much sense. At the most, we can count that how many males and how many females. But in a quantitative data, the number of hours spent with the social media, is it a heavy user, a light user? Based on the numbers, we can find the mean, we can find the standard deviation, and we can do a lot of hypothesis testing also with the actual numbers. And qualitative data, we said that there are two types of qualitative data. One, the data is equal and there is no hierarchy. Another set of data, there is a hierarchy. Movie rating and gender, example. In a quantitative data, we said these are typical numbers. Behaviors or activities are measured in terms of numbers, and here we can classify the numbers in two types. One is continuous data, another one is discrete data. So continuous data means the data that can take any value in a given interval. It's not a whole number, and it can take a fraction. For example, number of hours spent with the social media. 4 hours, 10 minutes, 35 seconds. So like that we can have a fraction, and money can be measured. For example, 199 rupees 90 paise. Here all these are not whole numbers. Here numbers are with the fraction. This is called continuous. It can go on like that. 199 rupees 91 paise. 12 hours 49 minutes. Like that it goes either backward or in the forward manner. Numbers are not full numbers with a fraction. This is called continuous data. Another set of data under quantitative classification is a discrete data. Discrete data can take any one particular values, and there is no between intervals. There is no fraction is possible. If there is no fraction is possible, and that number is classified as a discrete. If there is a fraction is possible, interval is possible, that's called continuous data. For example, for discrete data, we can say number of students in the class. We can't say that here it's a 5 students, 5.3 students, 8.9 students. We can't say like that. So here it can be taken only full numbers. So that's called discrete. If there is a number that can go with a fraction, that's called continuous. The number takes only whole value, that's called discrete number. Now we'll come back to the level of measurement. So we said qualitative data based on the characteristics, all are equal, gender, there is a hierarchy. And quantitative data, we have discrete, we have continuous, full number with a fraction. Now we'll associate this classification of qualitative data and quantitative data with the levels of measurement. When you're saying qualitative data, we have two types of level of measurements. One is nominal, another one is ordinal. The nominal level of measurement characterized by the data that consists of names, labels, and categories only. Cannot be ranked, cannot be ordered, and there is no difference between the categories. Gender, eye color, ice cream, all these are classified as a nominal data, and here we can do the categorization based on the characteristics, and we can take the only names and we can count that. And another set of qualitative data is ordinal data. Ordinal level of measurement, here qualitative data that can be arranged in some order, and such as low to high or high to low. Example, star rating of movies, 5-star rating, 4-star rating, 3-star ratings, and letter grades of test, excellent, very good, poor. You can understand that the difference between 5 and 3, one is good, one is average, but you can't measure that how far it's very good from average. We can't measure that. We don't know the gap. But we know these are in a different order, but we don't know the gap. Whereas in nominal, there is no gap at all are equal. Here there is an order, but we don't know the gap between the two ratings. Next level is a quantitative data. Here we have discussed about continuous and discrete data. Discrete data or continuous data again can be classified into two levels of measurement. One is interval, another one is ratio. And ratio and interval, the difference is the interval, the 0 has a meaning. The ratio, 0 doesn't have meaning. But both measurements carries the values of continuous data as well as discrete data. Both continuous and discrete can go in an interval, can go in a ratio also. But the ratio and interval, the difference is the interval data has a 0, but it has a meaning. Ratio also has having a 0, but doesn't have any meaning. For example, the weight of any object, we can say 0. The performance of person in an exam got a 0, and the number of hours spent in social media is 0. Here all the zeros has some meaning. It means nothing. The weight of 0 is there is no weight at all. And the person spending with the social media 0 hours means not at all connected with the social media. So nil, nothing is being associated with the 0. In the interval level, when we are saying 0 temperature, doesn't mean that's not existing of any temperature. You can see the difference in temperature in terms of Celsius and Fahrenheit. If 0 is a Celsius, the Fahrenheit gives a different number. So in the interval, 0 means there is a meaning. In a ratio, 0 means nothing. The starting point is a 0 in a ratio level. So that's the difference between these two data of quantitative data. In summary, we can say that data can be classified as a qualitative and quantitative. Qualitative data can be classified as a nominal or ordinal. The difference is nominal are equal, ordinal is an order, but we don't know the difference. And the quantitative data can be classified as a discrete or continuous. Further can be classified as interval or ratio. Discrete is a full number, continuous is a full number with a fraction. Both can go in interval in a ratio manner. Interval as a meaningful 0, ratio 0 means nothing or empty. So this is the graphical representation of the whole discussion about the data type. Data type is a fundamental component of statistics. If you know this is the data, we are generating nominal data and we can do the counting. If we do the ordinal data, it means ordinal means we'll give the order and hierarchy. We can find the relationship, we can find the differences. You can use as a Spearman, or you can use other relationship tools. And nominal data means you can do the chi-square test and counting can be done. If the ratio, you can do the Pearson, t-test, f-test and all. So based on the data type, we can go for specific statistical tools to identify the relationship or identify the differences. With the nominal data, you can't go for statistical tools which are meant for ratio. So statistical tools meant for ratio has to have continuous data or discrete data. If you have nominal data, then we have to use the statistical tools meant for nominal data. So for that kind of statistical applications, you need to know the data types. So that is the summary we are giving: qualitative and quantitative, discrete, continuous, nominal, ordinal, interval, ratio. Hope you will understand the basics of this data types through this video. That is a fundamental component of the statistical application for quantitative study. Thank you.